When an object falls in air, it will experience some air resistance force. So in this example, we do have gravity pulling downwards on the skydiver and an air resistance force upwards. If the person is still accelerating, these two will not be equal to each other. Our net force is as follows. Force net equals force of air minus force of gravity. Air is going up, gravity is going down. That's why we have it assigned a positive and negative. Now we always plug in mass times acceleration for force net. Our air resistance force is recorded at 50 newtons at the moment. And then we'll subtract the force of gravity of the person. We can then solve for acceleration. Acceleration equals negative 9.0 meters per second squared. Now what if we are at terminal velocity? Well, terminal velocity, that means we will not be accelerating any longer. So now I will put a 0 in for force net. And I will then solve for my force of air minus force of gravity. Okay, so 0 equals force of air minus 60 times 9.8. And we see that the air resistance force at terminal velocity would equal 588 newtons, or meaning it would be equal to the weight of the person. In an elevator question, we need to consider again what forces would be acting on the elevator as it accelerates upwards or downwards. Force tensions, in this case, will be pointing upwards, and force gravity will be pointing downwards. We see that there are three tension forces in this example: force tension 1, force tension 2, and force tension 3. They will all follow a similar pattern as this. The force net will equal force tension minus force gravity. What will change is what the tension force is acting on. And to find force tension 1, we are going to say the force net equals force tension 1 minus the force of gravity. When we plug in for force net, we need to plug in a value for all of the masses added together, including the mass of the elevator. So you will then say 518 multiplied by, we read the caption and find that the acceleration is 2.3 minus force tension 1, or rather equals force tension 1, minus force gravity, which would be 518 multiplied by 9.8. We can then find the value of force tension 1. Force tension 1 rounded to 3 significant digits would be 2,380 newtons. We can then follow similar patterns of problem solving. If we want to find force tension 2, we would say force net equals force tension 2 minus force gravity. Now let's ask, what mass does force tension 2 have to hold up? Well, it looks like it has a 6 kilogram it has to hold up and a 12 kilogram. So then we will say 18 times A is equal to force tension 2 minus 18 times 9.8. We do know the acceleration, so we then go 18 times 2.3 equals force tension 2 minus 18 times 9.8. Acceleration of the boxes would be the same acceleration as the elevator. So force tension 2 has a value of 218 newtons. And finally, we have force tension 3 to solve for. Same equation, force net is equal to force tension 3 minus force gravity. And once again, the acceleration of this box must also be 2.3. We'll start by plugging that in right away. 12 times 2.3 is equal to force tension 3 minus 12 times 9.8. Force tension 3 has a value of 145 newtons.